All right, now I'm gonna show you guys how um, the equations of motion came into existence. So, what are the equations of motion? Let's just write that down first, right? So the equations of motion. All right, so we got the first one. You might have learned this in I don't know ninth grade, right? Um, I'm just gonna let's just do a quick recap on that. So the first one I'm gonna write is v is equal to u plus at. Second one is v squared is equal to u squared plus 2as. And the third final one is s is equal to ut plus half at squared. Cool. How in the world did these equations come into existence? The word for that is how to derive those, right? How did people who made them derive them? The person who made them derived them. So let's just do a little thing here. Let's try to find what are all the variables in all these equations. So first, obviously, we've got v. Then there's u, right? There's u. Then there's a. And then there's t. And then there's s, right? And then there are the numbers, which are just constants. So let's just leave the constants. We're just looking at the variables. So this is final velocity. This is initial velocity. I'll just explain these terms in a minute. So these both of these are velocities. Velocity, right? I'm just gonna put them. Okay, yeah, velocity. Both of these are velocities. This is acceleration. This is time. And this is displacement. All right? Okay, just remember that. So first, what I did was I took all the variables from these equations, wrote them down, and I just looked at what each of them were. Cool. Where do you think we can find all of these variables in? And at a single place. Now we can just get all of these. We can find all of these at a single place. That place is a graph by the name of VT. VT. And I'll tell you how we can find all of these. So let's say there's an object. There's a car, for example, that starts at some speed, some velocity, what 10 meters, might be 20 meters per second, might be 50 meters per second. I'm gonna call that number u because that's the starting velocity. Another word for starting is initial, right? Initial velocity. Initial velocity. I'm gonna call it u. So it started at this number u, and it's speeding up. It's speeding up, and by this much time, is that a straight line? Okay, this much time. I'm gonna call this the time t. But this much time it stops at this velocity. What's this velocity? I'm gonna call this the final velocity because it stops. It ends. Another word for ending is final. It stops at velocity v. Okay, so we've got starts at velocity u, initial velocity, ends at velocity v, final velocity. Great. Now in the previous video, this is a recap for those who haven't watched the previous video. The slope, two things to know about the VT graph is that the slope of this graph gives acceleration. And another thing, let's just do 1, 2, yeah. Another thing in this graph is that the area under the slope, so this area, you can see all this area, right? This area gives us displacement. Displacement was written with s, right? So I'm just gonna write s over there. Cool. Just remember this. I'm gonna put it in a little box for you guys to remember. All right, just give me a minute. All right, cool. Now, when we're talking about slope, in the previous video, we found out that acceleration is just 2 points. A slope is just 2 points by the 2 points over here. So it's v, if I'm taking these 2 points, the point v minus the point u, over these 2 points, the point t, and this is 0, obviously. T minus 0, that's just t, right? Let's just, okay. A is equal to v minus u over t. That's the slope. Slope of this line. A is equal to v minus u over t. That means if I transpose t over this to the left-hand side, LHS, I get AT is equal to v minus u. If I transpose minus u to the left-hand side, it'll be plus u. That means v is equal to u plus, this is plus u. I'll just write AT actually. So v is equal to AT plus u. Or I can write v is equal to u plus AT, correct? If you look carefully, look real carefully, this was originally that. So we just derived the first equation of motion. Great. Now let's look at the second one. And we don't want the second one to be squares. Or forget about the square. Let's try to find displacement, because from here we found acceleration, we found that. So let's just do the second one, displacement. How do we find displacement? We find the area. How do we find the area? Well, we find the area from here. Well, that's the area of a, what is that? Is that a parallelogram? No, that's not. Oh my god, that is not a parallelogram. What is this? A quadrilateral. I don't want to find an area of a quadrilateral because that's a weird shape. I want to make it simpler. So how do I make it simpler? I can divide this into two simpler shapes. So now it's a triangle over a rectangle. So I can just find the area of this rectangle and the area of this triangle. I can add them to get the area under this whole slope, right? And then that's my displacement. So look at that. What's the area of this rectangle? Let's start with the rectangle. Rectangle is breadth into length. So the breadth is u, right? So it's u into the length is t over here. So now this is just ut. Alright, cool. That's the area of the rectangle. Leave it there. What about the area of the triangle? What's the area of a normal triangle? It's half into base into height. So half into base, the base here is the same as this length. It's just t, right? So this is just t. So it's half into t into, what's the height? This height. What's this height? This height, if you look carefully, this height is the same as this height. What's this height? That's this height minus this height, right? This v, this height is v, minus this height is u. V, take away u from that, you'll get v, this one. So v minus u is this height. So it's what? It's v minus u. Now, I don't want, I'll just write, so the breadth we found is t, and our height I got is v minus u. Cool. Now, I don't want a minus in my multiplication over here. So what I want to do is I want to replace this with something else that could make it simpler. And if remember, the same thing can be found over here from our first equation. A is equal to v minus u over t. Transpose t over this side. At is equal to v minus u. V minus u is equal to at. So I can replace v minus u with at. Right? Cool. So essentially, my whole expression becomes half into t into at, which is the same as half at squared. So this I get over here is half at squared. Cool. Now the area of the triangle becomes half at squared. The area of the rectangle is ut, right? And what's the area under the slope? That's the displacement. So I can write S is equal to, displacement is equal to I add these. I add ut, the area of the rectangle, plus the area of the triangle half AD squared. And if you look really carefully, I can find the exact equation in my equations of motion. You should look at that. S is equal to ut plus half AD squared. S is equal to ut plus half AD squared. There we go. 2, 4, 2. Great. So we found this one and we found this one. What about this one? What about that one? Do you notice how there's no t in this? There's everything but t. So that means t must have been plugged in into some equation and the t's got cancelled out. Right? That's what we're gonna do. We are gonna replace everything in this equation. We're gonna take this equation, right? We're gonna take this equation, s is equal to ut plus half AD squared, replace all the t's with something else. Alright? How do we do that? We need to know what t is. To replace t with something, we need to know what t is. So earlier, we found out v is equal to u plus at. I can transpose u to the other side to find v minus u is equal to at. Right? It becomes minus. And I can isolate t by bringing a to the left-hand side. So v minus u over a, multiplication becomes division to the left-hand side, becomes t. So I get t is equal to v minus u over a. Cool. So look at that. Alright? So now I just found out something that I can replace t with. I'm going to use this in this equation. Which one? S is equal to ut plus half at squared. Okay, so s is equal to u into v minus u over a plus half a into v minus u over a into v minus u over a, because it's t squared, so it's t into t, right? T into t. Cool. Now v minus u by a over a is common in these two terms. This one term, this is another term, so we found the same over here, so I'm going to take it outside. S is equal to v minus u over a, the whole into, okay, the whole into, we took it outside, so it's going to be u, v minus u over a into u gives me this. When I take it outside, it's going to be u plus half a into v minus u over a. One of these remains because, well, that's how, when we take one outside, one is going to remain, right? We took this one and we took this one outside, so one remains. All right, so it becomes v minus u into u, v minus u by a into u plus half a into v minus u over a. All right, cool. Now if you look carefully over here, I can cancel these a's because it's being multiplied. So that goes. So it's gonna be s is equal to v minus u over a into u plus half into v minus u, because the a's got cancelled out. This is, I'm gonna open these brackets up, so I'm gonna get s is equal to v minus u over a into u plus half v, plus half into minus becomes minus half u. Now this is a u and this is another u, so u minus half u. What's 1 minus half? What's 1? This is 1 u minus half u. Another half remains, right? So it's going to be s is equal to v minus u over a becomes half v plus half u. Okay, u minus half u is just half u. I wrote it like that. All right, cool. Now you see that half is common in these two terms. I'm going to take that outside as well. So s is equal to v minus u over a. Half I took outside, and in the bracket remains only v plus u. I can rearrange these terms. S is equal to half into v minus u over a into v plus u. Alright? You realize I just changed the bracket shape. I'm going to break the bracket shape over here like that. I just changed the bracket shape over here. Cool. Now this is v minus u into v plus u, which is the same as a minus b into a plus b. that formula, that identity gives us a squared minus b squared. So that means v minus u into v plus u should give me v squared minus u squared. So s is equal to half into v squared minus u squared over a still remains. Okay, so it's 1 into this, that's the same as v squared minus u squared over 2a was equal to s, correct? Okay, I'm going to bring the 2a, okay, I'll just write over here. So s is equal to v squared minus u squared over 2a. If I bring this 2a to the left-hand side, because this is division, if I bring it to the left-hand side, it's going to be multiplication. So this becomes 2as is equal to v squared minus u squared, correct? And if I bring this u squared to the left-hand side, this subtraction becomes addition. So essentially it becomes v squared is equal to u squared plus 2as. And if you look really carefully, I'm going to trace this over here. I'm going to bring it all the way. Oh, would you look at that? We just found out the third equation of motion. And all from this graph right here. That's it, fellas. That's it. That is how you derive equations of motion. So, yeah, thank you. Oh my god. Thank you.